Even in the darkest depths of the ocean, many organisms have the ability to glow in the dark. Bioluminescence is light produced by a living organism and is one of nature's most amazing phenomena. It can often seem more like science fiction than science. While scientists don't yet understand the full purpose or function of this specialized adaptation, or exactly how it evolved, we do know that bioluminescence exists throughout the open ocean, from the sea surface to the sea floor, and we know that it aids ocean creatures for survival in a number of unique and quite creative ways. So let's take a closer look. Hi, everyone. Welcome to tonight's Educator Professional Development mini-series event offered through Noaa Ocean Exploration and our many Education Alliance partners around the country. As you know, tonight our focus is the phenomena of ocean bioluminescence. I'm Susan Haynes, and I'm thrilled to have you all here with us tonight. For today's program, we have participants joining us from a number of Central and Mountain Time sites: Dauphin Island Sea Lab in Alabama, Great Lakes Aquarium in Minnesota, Loveland Living Planet Aquarium in Utah, and Albuquerque Biopark in New Mexico. Welcome to you all, and I think our partners have a brief hello to share with you as well.
Hi, I'm Blair Williams. I'm the Youth and Family Programs Manager at Loveland Living Planet Aquarium. We're doing our bioluminescence follow-up on December 2nd at 3 p.m. Mountain Time. I hope you can join us.
Hello, my name is Juliana. I am the K-12 School Programs Coordinator at the Great Lakes Aquarium in Duluth, Minnesota. Our follow-up event will be held virtually on November 12th at 5:30 p.m. Central Time.
Hi, I'm Deborah from the Albuquerque Biopark Aquarium. Thanks for joining us on this awesome professional development on bioluminescence. Please join us for our follow-up event on November 16th at 4 p.m. Mountain Time. Thanks.
Good afternoon. My name is Tina Miller-Way, and I am your host for the follow-up workshop at the Dauphin Island Sea Lab. The Sea Lab is at the far southern extent of the state of Alabama, and we are just minutes from the Gulf of Mexico. We're looking forward to you joining us on December 7th at 5 p.m. Central Time. See you then.
I have to say, we are incredibly grateful for our enthusiastic partners, and I really love that squid bus and the pink flamingo earrings that Tina's wearing. So thanks to all of our partners, and we look forward to the follow-ups. And I also want to note that this program is made possible through a significant partnership with the University of Rhode Island's Inner Space Center and supported by the National Marine Sanctuary Foundation and the Ocean Exploration Cooperative Institute. And tonight I am joined by my colleagues Alexandra Puritz and Liz Holdley, who work with me at Noaa through the National Marine Sanctuary Foundation. Ladies, would you like to say hi?
Hi, everyone. Looking forward to tonight's program. Thank you for joining.
Yes, thanks for joining. I'm excited to share with you a bunch of bioluminescence resources for your classroom later tonight.
Great. Glad to see you, Alex and Liz. And each of us will be presenting some various pieces of your program this evening. So we sent you all a short introductory video on bioluminescence earlier this week, and we hope you had a chance to watch it. And we'd like to open up the program tonight with a quick question to you all and a question poll through the Mentimeter tool. And our question tonight is, according to scientists' best estimates, what percentage of organisms in the ocean water column use bioluminescence? Your answer choices are A, more than 90%, B, more than 75%, C, less than 50%, and D, less than 20%. And you can answer this with the Mentimeter code that you see on the screen or the QR code, either one. And while you're answering that, just a few bits for those of you who are first timers to our series. Our goal for these events is to introduce you to experts in different ocean science disciplines and to highlight their areas of expertise, and also to provide you with a number of great resources on specific topics, this one in particular being bioluminescence, and also give you that opportunity for the professional connection and conversations through the follow-up events. A brief plan for our 90 minutes together tonight. We'll start in just a few minutes with a question and answer from our bioluminescence expert. And then we will provide you with an overview of a bioluminescence classroom lesson. Actually, this one is focused on the science of light and color in the deep ocean. And I ask that you please have access to that during our event tonight. It's in the Bioluminescence Resources for Educators folder, or the document that we shared with you earlier. And you can either have that in print or electronically up on your screen. We're also going to walk you through how to access a number of different resource materials on bioluminescence from a number of different partners, and to remind you of your follow-up event dates and times at the end. So taking a look at your answers to our poll question, according to scientists' best estimates, what percentage of organisms in the ocean water column use bioluminescence? Most of you said 75%, and most of you were right. So it seems to me like a lot of you had the opportunity to watch the Deep Sea Dialogues video, and I hope you are all excited to be with us this evening. So just a little bit to share with you about our office, Noaa Ocean Exploration. We are a federal office that was established in 2001 with a mission to explore the ocean for national and also for international benefit, focusing on the fact that our global future depends on us understanding our ocean. So along with federally funded exploration opportunities on a number of NOAA vessels, Noaa Ocean Exploration operates the NOAA ship Okeanos Explorer, which is the only federal ship dedicated to ocean exploration. And we at Noaa Ocean Exploration and many partners like Ocean Exploration Trust, who operates the exploration vessel Nautilus, and Schmidt Ocean Institute, who operates the research vessel Falkor, we all target areas that no one's ever been to before. And in many respects, we really have no idea what it is that we might find. So we map the seafloor, we study water chemistry, and we explore the organisms that live throughout the open and the deep ocean. And we often find things that are completely new to science. And if you've watched any of our live feeds or amazing videos from our remotely operated vehicle dives, you'll know there's always something new to learn when we're exploring the deep sea. And we have an example here for you.
We are exploring the most unknown place on our planet that takes up most of the space on our planet.
It's the most extensive ecosystem for multicellular life on Earth.
So we're very excited about doing this first ever full day of midwater transect.
Oh wow, it's got nectar there as well. Oh my goodness. Something was eating something else? Oh man, there's more nectar there too. What on? Oh!
I love that narration from the scientist who was on our ship observing that expedition. That clip is from our very first recorded midwater remotely operated vehicle dive done during a 2017 expedition in the Musician Seamounts chain, which is just north of the Hawaiian Islands. And while the majority of our dives focus on surveying the sea floor to understand the habitat and the life there, we're starting to apply tools and technologies to learn about the abundant life that lives between the sea surface and the sea floor. And when you consider that our ocean is 3/4 of our planet, and the average depth is almost 4,000 meters, or over 12,000 feet deep, that is a lot of space. And now we all know that more than 75% of the animals that live in that space bioluminesce. So that's a lot of bioluminescing organisms. And as you saw in the Deep Sea Dialogues video with Renee Martin, there are many reasons for bioluminescence, and we'll dive a little deeper into this phenomena tonight with Renee. Additionally, just a reminder of the resource sheet that you received, and it's filled with a number of great resources for your classroom instruction. And again, we'll go through some of that tonight as well. So all that said, I hope you all arrived with some great questions for our expert tonight, and I'm going to turn it over to Alexandra.
Thanks, Susan. Hi, everybody. My name is Alex, and I am a member of the NOAA Ocean Exploration Education Team, and I'm excited to be speaking with Renee Martin today. Renee Martin is a PhD student at the University of Kansas Biodiversity Institute and Natural History Museum. Her research interests include the evolution and taxonomy of deep sea fishes, identification of larval fishes, and fisheries management, among others. Renee received an associate's degree in liberal arts and sciences from Century College and both her Bachelor of Science degree in ecology and field biology and her Master of Science degree in ecology and natural resources from St. Cloud State University. Renee, thanks so much for being with us today.
Thank you for having me. I'm really excited to both talk to you, Alex, and to talk to some of the educators that are listening in.
Great. So at this point, I'd like to ask everyone to please start sharing some questions that you might have for Renee about bioluminescence in the chat box, which you see to the right on your YouTube screen. And we will begin selecting from them in just a moment. But first, Renee, I have a few questions for you. My first question is, you do some pretty unusual and exciting research. What initially got you interested in this field of work?
So it definitely wasn't a straight path. For those of you in Duluth and for those of you that know where St. Cloud State is, I'm from Minnesota originally. And so I did grow up around a lot of lakes and around fish and fishing and camping and nature. And so it definitely started with that. And that is, of course, the largest fish ever. But as far as my getting into the deep sea specifically, it was a path of working for the fisheries department in Minnesota and then just generally being interested in fish behavior and doing some undergrad work and kind of falling into becoming a graduate student for an incoming professor that happened to be working on deep sea fish at St. Cloud State University. So although I had a kind of a continuing and ongoing interest in fish, the deep sea aspect and the bioluminescence aspect really came into play with just opportunity at St. Cloud State University. And it's very, very difficult not to enjoy bioluminescent organisms in the deep sea. And so once I realized that you could study deep sea fish in the middle of Minnesota, in the middle of the country, I jumped on the opportunity.
That's awesome. That's a great path. And I know we have a lot of people tuning in from Minnesota and other parts of the central and middle part of the country tonight. So I think that's especially relatable and a really great example of taking advantage of the different opportunities that you can find at your research institutions and universities. Great. So my next question is, so you're a marine scientist, but what does your actual day-to-day work entail?
So I have very, very small opportunities to actually visit the ocean. Currently living in Kansas, we do sometimes get the opportunity to go on deep sea trawls. So it's a very small portion of the work that I do, but still really important to collecting new specimens and to working on deep sea fish, especially when you can't necessarily reach them on a daily basis. Trawls are really expensive, and so having the opportunity to at least have been on one deep sea trawl was pretty fantastic. But again, a very small portion of my day-to-day life. I definitely day-to-day sit and work in the lab a lot and write papers a lot. Most of the specimens that I work on are museum specimens. So I work at the University of Kansas in the Biodiversity Institute, which is also the Natural History Museum. And a lot of kind of the general public don't realize that behind the scenes, behind all of the exhibits that you normally see in natural history museums, we actually house many specimens in jars that us as researchers get to use and utilize. And so my day-to-day is using specimens that have been collected from across the world and requesting some of those specimens on loan from other institutions and assessing all sorts of different things about these species. So whether or not it's using tissues to do DNA work or just looking at the bodies themselves to do different types of morphological analyses, much of my time is spent in the lab looking at museum specimens. And again, a lot of the time I do spend writing and doing computing. There's quite a bit of math and computing. Even in a biology degree, which going into it, you would not have initially thought. but my day-to-day is inside a lot as well.
Awesome. And before we open it up to participant questions, can you just tell us a little bit about some of the science communications work that you're involved in?
Yeah. So if you may or may not be familiar with this, but on Twitter, I started the hashtag called Sunday Fish Sketch. And initially it was just for myself. I had been interested in art on and off throughout my life, and I hadn't made time for it in probably over a decade, but I realized that, hey, I want to incorporate this into my life, so I might as well incorporate it into my work. And so I made the time and spent the time to practice on a weekly basis by drawing fishes. And it kind of snowballed into this huge community online where both scientists and artists post fish on a weekly basis. We support each other in regards to different types of illustration or working on different mediums, practicing. And it has been very beneficial in my scientific degree as far as making figures for publications or making really neat infographics for outreach to the community. And so I think it's just been really great. And for those of you that haven't seen it and are interested in fish and fish art, I would definitely look it up on Twitter. And yeah, I do have an Etsy shop. Sorry, I just saw that question. Or not Etsy, but at least an online shop. So if people are interested in that, I could potentially post it somewhere.
Yes, that would be great. We'll definitely get that from you and share it out with participants afterwards. So cool. Really cool combination of arts and sciences and combining interdisciplinary efforts. Cool. All right, let's start taking some questions from the audience, please. Jennifer asked, is bioluminescence as common in freshwater as it is in saltwater?
It is not. So I would say the huge majority of bioluminescence and bioluminescent organisms occur in the marine system. Freshwater, there might be one or two fish species. I would definitely have to take a look back into that. And even with those individuals, it could be that they are species that have ancestors that were marine organisms that have moved into freshwater systems, and bioluminescence or the photophores they may have is they're kind of like a relic of the ancestor of their past. And part of this is because you don't generally have organisms that have luciferin or luciferases or the bioluminescent bacteria that would occur occurring in freshwater systems. They're occurring in marine systems. Oh, Alexandra, you're muted.
Can you hear me now?
I can.
Thanks. So why is it that bioluminescence is so prevalent in the deep and open ocean as compared to freshwater, for example?
So a lot of the organisms that live in the deep sea, if you think of the deep sea as a whole, it's very deep. There's a reason it's called that. And as light filters through the ocean, a lot of the different colors and wavelengths of light get filtered out very fast. And so both the intensity and the light spectrum as you're getting deeper in the ocean decreases till you just have, frankly, a blue-green hue. And so the organisms that have invaded that realm and that live in the deep sea aren't going to be able to see each other like they would potentially in freshwater systems. And so the evolution of different ways to communicate and to predate on others, one of the ways to do that is to basically evolve the ability to bioluminesce and to make light in order to communicate.
Got it. Great. Thank you. Great question, Jennifer. Let's open it up to another one, please. Martha asked, how do organisms light up in unison, like synchronous bioluminescence?
Synchronous bioluminescence. It depends on, I guess, the organism. And so if we're talking about bacteria and bacterial bioluminescence, and so when you see like those really cool videos of the waves crashing on shore and everything is glowing at once, they have something called quorum sensing where they give off these little chemicals, and once there are enough of them in the water and the bacteria when they kind of these chemicals that they give off touch each other, they're like, hey, there's a bunch of us here. They will then bioluminesce, and it's called quorum sensing. So that's one of the ways they can synchronously bioluminesce. Regarding different shoals of fishes, I'm honestly not sure, and it's kind of hard to tell just because of the fact that we can even still hardly observe a lot of the bioluminescence that's going on in the deep sea. And so understanding the why and the behavior behind that has been very difficult. But at least for bacteria, we know it is quorum sensing.
So that, and it sounds like there's still a lot we don't know about certain parts of bioluminescence. So great for future scientists to figure out. All right, thanks, Martha. Next question, please. So Loveland Living Planet Aquarium said, you said that scientists agree that there were 94 different points of evolution of bioluminescence. How different are those 94 adaptations from each other?
That's a great question. And one I'm definitely, since I study evolution and I study the evolution of these things, one that's kind of close to my heart. And it's not so much in agreement that there's only these 94 points. It's just with the current knowledge and the current data that we have, we know it's happened at least 94 times. The surprising part of that is a huge portion of those are very similar, because some of those evolutions of bioluminescence is just the evolution of an organism being able to house bioluminescent bacteria. And so anything that can do that is basically just creating a space in its body that then can like culture and house bacteria that are bioluminescent. And so whether or not it's an allure on your head or allure in your chin, those are all kind of similar in the sense that they're housing a bunch of bacteria. As far as organisms that can actually bioluminesce themselves, so they have the organs to do so and they can do it intrinsically with their nerves, there's a bunch of different ways. But a lot of those organs are still very similar to each other. So the group that I study are the lanternfishes, and they have these primary photophores. And those photophores can, let's say, be very similar to some of the bioluminescent photophores you see on a hatchetfish. So there's definitely adaptations that are super similar, and there's definitely some that are extremely different.
That's so interesting. Thanks. Great question. And thank you all. Keep these questions coming in the chat. We love it. Next one, please. How to use Schoology in the classroom asked, is bioluminescence in the deep sea the results of a symbiotic relationship with bacteria, or is it an example of convergent evolution?
So those are two slightly different, I guess, answers to that. So, and like I just previously mentioned in the last answer, some of the organisms do have a symbiotic relationship with these bacteria, where they're housing them in different organs or pouches in their bodies. But that can still technically be considered convergent evolution. So if one fish group evolved the ability to house bioluminescent bacteria separately from a different fish group that also evolved the ability to house bioluminescent bacteria, that's technically an example of convergent evolution. But again, that's not the only type of bioluminescence. You do have organisms that have the nervous system and have the photophores that can do it themselves. And those, again, would still be convergent evolution of nervous system bioluminescence.
Okay, got it. Good question. Thank you.
Yeah, definitely.
All right, next question, please. Lindsay asked, what determines the color that organisms display? Does it decrease with age, or is color or light strength determined by health or food source?
So light color is actually controlled by a bunch of different factors. That's a super great question, a very complicated answer. Some organisms, it's truly just the type of luciferin or luciferase that they're using in the group. Color is actually like not only the light organ itself and the luciferin and luciferase themselves, but if you like some of the scales that lay on top of those light organs also help determine what ends up being the final color. So it is very complicated and it really depends on the species. In some dragonfishes, so like the stoplight dragonfish or the loose jaw, it has a bioluminescent photophore that's red and it glows red. But that red light, the actual light that that organism creates isn't red. It's got a filter over that organ, and that filter is what makes it red. So the colors and the reason behind the colors are completely different depending on the species. And then as far as if it decreases with age, I can't say I've heard of that, but that one I'm not sure about. I would have to look into it. And then as far as the strength of the color, it also depends. So, and again, I focus on lanternfishes, so my answers might be lanternfish focused. But in lanternfishes, sometimes the intensity of that light is very specific to the depth of the ocean that they're in. So if they're higher up in the ocean and the light that's coming down is brighter, their light will actually be more intense to match that. So some of that strength comes from just the fact that they're in different layers of the ocean. And then some of it is food source. So especially in a particular species of fish called Perichthes, they actually, the species that live kind of up in near Washington on the coast, Pacific Ocean, they have the photophores, but they can't bioluminesce because they don't have the food source there where they would normally be eating like little copepods that are bioluminescent. But since there's none of that species there, they can't, the fish themselves can't bioluminesce.
Interesting. So it seems like a simple question, but the answer is complex. But this is great. It actually relates a lot to the activity that we're going to be demoing in a few minutes, looking at light and color in the deep sea. So perfect primer for that. Thank you. All right, we have time for a few more questions. Next question, please. Mary Boop asked, is bioluminescence the reaction similar to nerve impulses? It almost seems like reflex for these organisms. What is the mechanism that triggers it?
So similar to my last answer, also very complicated. In some fish that house the bacteria, for example, it isn't a nerve impulse. So since the bacteria themselves are doing the bioluminescence, and it's the quorum sensing that allows for that bioluminescence, it's possible that agitation of the pouch that's holding them is what ends up creating the bioluminescence. Sometimes the fish have an organ that actually has a shutter on it. So in flashlight fish, they have huge bioluminescent pouches right under their eyes, and some of them can actually rotate that shutter open or closed. And so that is something that they do not necessarily impulsively, but are doing it purposefully to either look for prey. In lanternfishes, they have multiple different types of light organs. So some of them are on like the ventral surface of their body, which is used in counter-illumination, and that may be more impulse than it is actual intent. Whereas they also have light organs on their tails and on their heads, which are thought to be used in stunning or communication, and that also might be more the actual individual using and thinking about using a certain light organ at a certain time. So it is, again, very complicated. And there's a bunch, since bioluminescence has evolved so many different times and it has so many different purposes, we can't put them all in one category or another.
And I know we touched on this a little bit in the video, but can you share a bit more about some of the different types of adaptations that you were just starting to mention?
Yeah, so some fish use bioluminescence for what I just mentioned, counter-illumination. If you think of anything that is, like think of a bird and it's flying above you and the sun is out, it casts a shadow, you can see its silhouette. And so what counter-illumination actually is and what it does is these fish and other organisms actually have light organs situated on their bellies. And those light organs, they'll turn on and they'll generally match both the color and the intensity of light that's coming from the surface of the ocean. And that effectively obscures their silhouette from predators that may be below them in the water column. So that's one major purpose of bioluminescence in the deep sea. But again, other fish like anglerfishes and dragonfishes that have head barbels and chin barbels are using them to attract prey items. A lot of the fish and a lot of the organisms in the deep sea actually eat tiny little zooplankton like copepods and amphipods that they themselves are bioluminescent. And so having a lure that might match a little copepod flashing is going to be really, really great because you might pull in a bigger fish and then be able to eat that fish. Some organisms in the deep sea can squirt out bioluminescent goo. And so that can actually like stun or confuse a predator as then that organism swims away. And a couple different organisms have really bright flashing patterns that again can stun and confuse prey. Lanternfishes, or at least some species of lanternfishes, have these huge headlight organs that's thought to just help in looking for prey items. So there's a wide range of behaviors and evolving bioluminescence and then being able to utilize it for a bunch of different things is important for success in the deep sea because again, over 75% of the organisms that live here are able to bioluminesce.
It was really evolved out of necessity.
Yeah.
Interesting. And also from your great descriptions. I know we just had Halloween, but if people are looking for costumes for next year, sounds like there's some great bioluminescent deep sea organisms you could dress up as if you're creative. I think we have time for one more question before we head over to our next section of the program tonight. Chenin asked, do male versus females bioluminesce differently? Do they have different patterns, different colors?
So that is, again, species dependent. Some species, and whether or not it's a fish or a squid or any organism that bioluminesces, might have, the males and females may have similar bioluminescence, whether or not it's the shape of their light organs or the flashing patterns. But in other species, they could have differences between the two. It's different, or it's difficult, at least in some fish species that are really deep in the ocean, to look at whether or not flashing patterns are happening, like in fireflies, just because we are still developing the cameras and the technology to be able to effectively see bioluminescence in the deep sea. But again, using lanternfish, some males and females have something called sexual dimorphism in their light organs. So the male might have larger light organs where the female might not. And so the fact that males and females do have different light organ sizes makes us believe that, yes, there's some sort of communication and sexual selection going on. And so in lanternfishes, at least, males and females do have different types of bioluminescence, but it is specifically in the shape and the size of the organs in some species, not in all species. And it is seen, there is a really great paper that actually talks about this, that, of course, I read the fish section, but it does occur. And I would need to look into it a little bit more to answer whether or not there's other colors. But it's definitely prevalent in the deep sea.
Interesting. Okay. Sounds like mostly shape and size for organs. Very interesting. Well, I actually read the time wrong, and I think we have a few more minutes for some more questions, which is great because we still have a lot more to answer. So if you don't mind, we'd love to ask the next question, please. Lindsay asked, it also brings people into the discussion who might not otherwise talk about fish, since you're reaching out to people on the artistic level. So I guess more of a comment than a question, but maybe you could elaborate on some of the outreach experiences you've had through some of your science illustration work. And I believe we have a few other photos maybe that we could share as well.
So my scientific outreach isn't, and it's tied to art, isn't solely on social media. I have used different figures that I've made and different really cool infographics for doing outreach here at the University of Kansas. We'll have people come in, and I made a really great infographic talking about our collection and the strengths of our collection. We also go to different places in town and basically have events where we can reach out to the general public about what behind the scenes things that we're doing in the Natural History Museum, whether or not it's our own personal research or the collections themselves. All of these were basically, and all of the infographics were made because I really just tried to dig in deep and connect my art and my interest in art to my interest in science. So other than that, let's see what else. I've done a couple different things associated with art and science and judging really cool sci-art projects and reaching out through different web page organizations. There's a lot to be said about trying to incorporate art and science and pulling in individuals that have an artistic background that also might have and want to dabble in science, and vice versa. There's no reason they have to be separate. And I think it's really beneficial to try to incorporate the two.
That's awesome. I must say you are extremely talented. It's really amazing to see your work. Thank you so much for sharing that with us tonight.
No, thank you.
And along the lines of kind of finding different paths to blend together, do you perhaps have any advice that you might give to students who are kind of interested in pursuing some of these relevant career paths? What advice would you give to students?
My main advice, I guess, would be to not worry so much about if you've been out of school for a long time or if you're taking a long time. I'm in my PhD program right now, and I'm finishing up within the next year or two. And I will say that I've been in school for probably 28 years of my life. I didn't get my associate's degree until I was in my mid-20s, and didn't get my bachelor's until a few years later. And so I guess I would say, one, just because you've been out of school for a long time or you're taking it slow, that doesn't matter. Like, you can get back into science. You can get back into any sort of graduate career at any age. No one's going to put you down for it. No one's going to think that you're taking too long, because honestly, I've taken a very long time. And second, and if I'm any testament to that, you can kind of study anything that you want from anywhere at this point. We have such a great connection with the internet and with social media and with being able to reach out to different universities and different museums that I can be in Minnesota or I can be in Kansas and study deep sea fish. And so look into it, and don't be put down by thinking that just because you're locked in a certain area that you still can't study something that you're really interested in.
That is such good advice. That's awesome. I really appreciate that.
Yeah.
Thank you so much for sharing that. I think that we're going to head over to our next section of the program. But Renee, thank you so much for being our guest expert today. And do you think you might be able to stick around for another question or two at the end if we have the time?
Yeah, absolutely. And thank you for having me. This was great. And it's so great to see so many educators watching. Feel free to reach out to me anytime. You know where I am, the University of Kansas. So
Awesome. Thanks, Renee.
Yeah, thank you.
So as we've seen from Renee, bioluminescence is very complex and very fascinating. So now we're going to shift to sharing the bioluminescence instructional resources that we have available to help cultivate student interest in this amazing adaptation. So now I'm going to turn it over to you, Susan.
Thank you so much, Alex, and thanks so much to Renee. What a great question and answer session. You guys are tossing so many terrific questions at our team. I hope we can answer as many as possible tonight, and glad that Renee is going to join us back a little bit later. So as Alex said, we're going to switch to some resources now. And as I mentioned earlier, you have the Bioluminescence Resources for Educators document that we shared with you prior to today's event. And there you're going to find a whole bunch of pieces of information. We are highlighting resources from multiple organizations, and we have 2 middle school activities there, which are scalable depending on where you want to take your students. One is an investigation of the science of light and color in the deep ocean. That's the one we're going to cover tonight. So again, please be sure you have that one in front of you, either in print or electronically. And then the other one is Bioluminescence, an adaptation for deep sea survival, which you're going to explore more during your follow-up event, and you'll have access to very shortly. You also have a number of fact sheets. There's a fact sheet on bioluminescence. There's one on 3 mysterious light effects, being bioluminescence, phosphorescence, and fluorescence. There's a fact sheet on light and color in the deep sea. And then there are a number of exploration notes, which are first-person accounts from scientists exploring these environments. One is called Lights in the Dark from Ocean Exploration Trust and focuses on some of the technologies for exploring bioluminescent organisms. One is called Not So Bloodthirsty, an encounter with a vampire squid, also from Ocean Exploration Trust and quite fitting for Halloween week. And the last one that we have is called the Medusa Lander from Noaa Ocean Exploration. And this one was written by Dr. Edie Witter, who is a bioluminescence specialist. And the Medusa Lander is the tool that captures really amazing footage of deep sea predators in their natural environment using the electronic jelly to lure them in. And that is the tool that captured the very first in situ footage of the giant squid in 2012. So again, a number of great resources. And now we'd like to ask you if you would participate in another poll. There's a poll number for you that will pop up on the screen in just a moment. And our question for you is, how interested are you in incorporating bioluminescence into your classroom instruction? A, I can't wait. B, I might use this. And C, this doesn't really fit in my curriculum, but I hope to share it with other people. So take a few moments to answer that. And while you're answering, a few things I want to share with you. The activity that I mentioned that we're going to talk through, again, is an investigation called Science of Light and Color in the Deep Ocean. And this is a middle school level activity that we approached with some guidance from our colleagues at the National Science Teaching Association. And it was developed by one of our several amazing NOAA ocean exploration facilitators, this one who happens to be a classroom educator. And this activity was approached using the 5E instructional structure, engage, explore, explain, elaborate, and evaluate, but also with a focus towards student-oriented investigation and sense-making, meaning that the students are really actively trying to figure out a science concept and understand a phenomena. And really, they're taking a journey of discovery and understanding through the process of the activity and the investigation. So let's take a look at your poll answers. Looks like most of you can't wait. Some of you might use this, and a few of you aren't quite sure this will fit into your curriculum, but you might share it with others. That's great. And just a reminder, and I'm sure many of you consider this when you're teaching, you can teach just about any science subject using the ocean as an example. And in order to encourage ocean literacy and ocean understanding amongst our K through 12 students, I encourage folks often to use ocean science topics to teach multiple science concepts. So with that, I am going to share my screen, and we're going to pull up the Science of Light and Color in the Deep Ocean lesson. And you'll notice as you take a look through this on your own that there are several pages of instruction, and pages 11 through 13 are where you will find a student handout. And this is what the student handout looks like. Again, it goes through several pages, and we'll scroll through that perhaps a little bit later. This handout is also available in Word so that you can modify it as you need to. And you'll be shown links on where to find this on our website in just a little while. So as you take a look on the first couple of pages, we provide the educator with an overview. And the focus of this is for the students to explore the phenomenon. Animals throughout the ocean animals throughout the ocean depths are different colors and use different colors of bioluminescence. Why and how do they do this? And the students will also investigate how light interacts with different materials and make connections between the observed phenomenon and what happens to light as it passes through the ocean. A few of the objectives and learning outcomes: the students will do a deep sea light and color simulation investigation and come to some conclusions based on their results. They'll also create a model for waves that includes how the amplitude of a wave is related to the energy in a wave. And they'll evaluate the relationship between color, energy, and wavelength of light in the ocean. And as you scroll down a little further on the first page, you'll see some connections to the next generation science standards. This lesson in particular supports the performance expectation MSPS 4-2, which is waves and their applications in technologies for information transfer. And you can see the DCIs that are listed there, wave properties and electromagnetic radiation. Certainly, depending on how you approach this lesson, you might be able to tackle other DCIs and also other cross-cutting concepts in science engineering practices. But you can see the cross-cutting concepts and the science engineering practices that we particularly targeted with this activity. And you'll see the common core connections. And I also want to bring to light the ocean literacy essential principles and fundamental concepts that this activity supports. First, it supports principle number 5, which is the ocean supports a great diversity of life and ecosystems. And within those fundamental concepts, it particularly supports fundamental concept D, which is ocean biology provides many unique examples of life cycles, adaptations, and important relationships among organisms, particularly symbiosis, predator-prey dynamics, and energy transfer. This lesson also supports ocean literacy principle number 7, and that is that the ocean is largely unexplored. And the target here was fundamental concept B, which is understanding the ocean is really more of a matter of curiosity. Exploration, experimentation, and discovery are absolutely required to better understand ocean systems and processes. So as we scroll a little bit further into the activity, page 2 covers all of the materials that are necessary for this lesson, including hands-on components, links to worksheets and fact sheets, along with multiple image and video links to support your instructional sequencing and learning. And we'll walk through several of these pieces as we progress. And as we scroll down to page 3, there's a brief bit of educator background information and links to all 3 of those fact sheets that I mentioned earlier, either for your reference or for your students. And then we move into the meat of the activity itself, starting with the engage section, which introduces students to the phenomenon. Again, that phenomenon is animals throughout the ocean depths are different colors and use different colors for bioluminescence. Why and how? So as we move down a bit on that page, you can start by stimulating the students' thinking, either with a think, pair, share approach or whatever instructional strategy works for you to get them talking with each other, and introducing them to their light and color worksheet, which again is on pages 11 through 13. And you could prompt them with a few key questions, like, can you think of animals of different colors and what their colors might help them to do? Or what colors do you think animals are deeper in the ocean where there's less light? Or what about the deepest parts of the ocean where there's no light? Do you think they're different or the same as they are at the surface? And at this point, you could think about having the students draw and color a diagram of their preconceptions of animals at different depths that they can compare to later once they've gone through some of this instruction. And next, on the right-hand side of this page, you can see that you can set the stage by walking the students through a guided imagery. And here they're taking a journey, they're traveling to depth, they're observing and collecting some organisms, and then suddenly they start to see glowing lights. And that piece ends on the top of page 4, and the students can record their thoughts related to the guided imagery on their worksheet. And then there are a number of prompting questions again. You could ask students things like, if we wanted to model going down into the deep ocean in our classroom, what could we do? And how might things appear differently 200 meters below the surface to an animal or a scientist studying how light changes deep under the water? Do you think the amount of light changes? And do you think anything else about the light changes? And the idea here is for the students to get to the concept of color, but you don't want to give this away yet. You simply want them to record their thoughts and share their best ideas. And then as we move on to the top of page 5, could we remind the students of the phenomenon? And then we're moving into a more hands-on piece of the activity, where we're going to give the students 3 to 4 strips of blue filter paper. And I'm going to walk you through these pieces. So the first thing I wanted to show you, and we can set the activity off the screen for a few moments. The strips of blue filter paper, those of you who are older might remember the term paper covers. That is one way to do this, but you definitely have to play around with this. It doesn't work as well as gel filter paper that you can purchase from Amazon or Walmart very cheaply. And this is what a sheet of that gel paper looks like. And this is what a roll of it looks like. And the size that you can order is about 16 by 19 inches, which is a lot to use for a classroom and can be reused multiple times. So pretty cheap materials for this. This gel paper is pretty flimsy. So having students be able to take this gel paper and hold it over their eyes is a little challenging. So an option is to create some file folder goggles These are simply cut out from your standard Office file folders with the little circles on one side and a taped piece of the gel paper on the other side. And so what I have here are, right now what I have here are 4 layers, but you can do 3 to 4 layers. And what the goggles are doing are assisting the students in going deeper down in the ocean. So we start with 1 layer and then we add more layers and they make some observations. But the idea here is to start with just having the students play around with the gel paper and see what it looks like in the classroom. And again, there are some guiding questions here. You can ask the students how the film affects the appearance of light in the room. Do things seem clearer? Do things seem less clear? Do colors look different? What is it like with 1 layer versus more layers? And how might this film help us to simulate what's going on down in the deep ocean? So through some basic questioning and some guidance, you can point students to the thought, but not directly, that some colors appear clearer and brighter and other colors appear darker or harder to see. And they might even notice that each additional layer of film makes the effect more significant. So then we move into the investigation itself, which is on the right-hand side of that page. And the students will play in small groups with 1 student assigned to be the predator. And that predator turns his or her back to the group. And the group will set up a number of small colored felt squares on a black background. And those colored squares are the prey. And so I taped my squares to my black background so I can hold them up to the camera for you. But this is my sequence of prey, and I have the same number of each color here on my black background. And each of these squares is about 1 inch by 1 inch. So your team will lay those out for their predator. And the predator is to imagine they're in the deep sea, either in the twilight zone or the midnight zone, depending on how much light you have in your room. And for each group, the predator, 1 predator at a time, is going to feed, first with 1 layer of film over their eyes, and then with 3 layers. So first 1 layer, and then 3 layers of film over their eyes. But first, the students need to go to their light and color worksheet and make a prediction for what their observations will be. So the prediction is, if you simulate going into the deep ocean, then blank color of prey will be the most camouflaged and will be eaten less than the other colors. So you can take a look at that there. So then we can instruct the students that the predator has 7 seconds to feed and can't turn around and start until you say go. And then with only their forefinger and their thumb, they can pick up 1 piece of food at a time, one prey item at a time, and place it into a cup. And then you can play this multiple times and record the results for 1 layer of film, and then repeat it for 3 or 4 layers of film. So what I want to do is illustrate what this looks like for you. So again, here is my prey, and note all the different colors. And I'm going to start with 1 layer of blue film. And now those of you who are in a hybrid classroom, this works great. And our friends at Waikiki Aquarium helped us learn this one. So if I hold up all of these pieces of prey, you can see what 1 layer of film does to the colors. And now I'm going to add 2 more layers. So this is 3 layers of blue film. And you can see what it does, and you kind of can see what it does depending on how close you hold it to the camera. But taking a look at this, I got to point carefully, this color right here, drop in the chat what color you think that particular piece of prey is. Again, this one right here. What color do you think that is? Somebody said yellow, white, blue, blue, yellow. Nice. Okay, so I'm going to take all of this off. That particular one that I was pointing to was, I can't put it up, was purple. So the purple ones and the blue ones showed up the best. Nice job, guys. And I will tell you, it's interesting that a lot of you said yellow because it depends on what kind of felt you buy and what kind of gel film you use. So definitely practice this ahead of time. I bought some felt the other day that had sort of some fluorescence in it. They were super, super bright colors. And the yellow was showing up like crazy. And that's not what I wanted to illustrate. So, so do be a little bit careful with that. The results that your student should come up with should look like this. And hopefully you all can see that. I wanted to pop it up so you could see both options. So with one layer of film, you can see that you get a number of different colors of prey that show up. You do get a lot of blue and purple, but you get a lot of other colors as well. And then with 3 layers of film, it really skews towards the blue and the purple range. So now you can have students start to try to figure out what's going on here. So moving back into the lesson and looking at page 6, along about the center, you've got some guiding questions to help the students start to build their understanding. And they can record some thoughts on their worksheet for numbers 8, 9, and 10. What patterns do they see in the data that they collected? Do some colors get eaten more or less than others? What kind of impact was there for 1 versus 3 layers of blue filter over their eyes? And do their results support their predictions? And I see that someone noted M&Ms as a possibility for this. Absolutely. And Skittles, absolutely. It all depends on whether or not you can use food with your particular students. Some folks have also mentioned construction paper, which is another quick and easy option. Just make sure you test out your construction paper. So then we move on to the top of page 7 into the explain section. And here we go more in depth into students formulating their understanding and kind of bridging that connection between color, wavelength, and energy, and how all of that relates to light in the ocean. So again, they're recording their observations on their worksheets as they progress. And in this section, they are exploring using a rope to simulate waves, and they have multiple guiding questions to get to the primary points of small amounts of energy equal slow moving waves and long wavelength, and larger amounts of energy equal faster moving waves with a shorter wavelength. And you have a series of multimedia options and question prompts that are offered to get students thinking about these concepts and guide them towards putting all of these pieces together. For example, you have a graphic of a prism where the students can observe and deduce what happens to light as it shines through a prism. I don't know if you guys have been challenged with trying to get light working just right going through a prism, but I had some challenges with it, and I love this graphic illustrating the light coming from the left side of your screen and going through the prism, refracting, and then you can see how the red wavelength is a slower moving, longer wavelength, and the blue and the purple is a faster moving, shorter wavelength. So then as we scroll to the top of page 8, the other resource that we have for you in the same realm is a graphic of a visible spectrum. And here we can illustrate that each color in the visible spectrum represents electromagnetic waves of differing lengths. Can we pull that image up on the screen for a moment? Great. So you can see that the portion that humans can see is right there in the center between ultraviolet and infrared waves. And then it illustrates that the shorter wavelengths are in the blue and the purple realm, and the longer wavelengths are in the red realm. And lastly, we also have a graphic of color penetration in the ocean. And this is illustrating that it's illustrating what we've been experiencing, which is that blue light penetrates the deepest and red light disappears first. So with that, you've got the key takeaways being that the order of colors is the same as the rainbow or the color spectrum, that different color wavelengths are longer or shorter, with red being the longest and violet being the shortest, that light bends into different colors when it enters the ocean, and colors of longer wavelength and lower energy are absorbed by water and particles in the water near the surface, and colors of shorter wavelengths and more energy penetrate deeper, being the blues and the violets. So then this section ends with students thinking about how color impacts animals' lives in the deep sea. And on the right-hand side of page 8, you'll see a link to a video called A Dark World of Color. And we want to show you just a quick clip from this 4.5-minute video that talks about color in the deep sea.
Animals don't necessarily want a particular color. They are made of particular molecules that absorb light in different ways, and the wavelengths of light that they absorb leave only some wavelengths to be reflected back, and it's the reflection of what's left is the color that we perceive. In the deep sea, those colors may be a product of what they have eaten. They may have defensive functions, so many of them are associated with some kind of a toxin or a defensive metabolite.
So that was just a short clip of a longer video with Scott France, who's one of our science leads on our expeditions, and it's a wonderful instructional piece on the world of color in the deep sea. And the idea here is that you could show this entire video once in full with audio, so the students learn these concepts, and then show it to them once without the audio and put the blue film over their eyes, have them put the blue film over their eyes. So that should help to really bring home the point that if red light isn't available to reflect off the animals into your eye, you can't see it. And that's why red animals are camouflaged so well in the deep sea, and that blue animals are particularly visible. Then moving on to the top of page 9 in the elaborate portion, this is where the bioluminescence piece comes in. And again, we're setting the stage with a few guiding questions for the students to get them thinking. Questions like, what challenges can you imagine organisms might face in the deep ocean? And can you think of any challenges that could be addressed by organisms making their own light? And based on what you've learned so far, what colors of light do you think would help the organisms in the deep sea stand out, or attract attention, or help them to camouflage? And then to introduce the phenomena of bioluminescence, we have a video again by Edie Witter, and this is created through Noaa Ocean Today. And we're going to show you a short clip of this particular video as well.
Bioluminescence is cold light made by animals, and most people are familiar with fireflies, and there are a few other land animals that can make light, but in general it's pretty rare on land. What most people don't realize is that it's the rule rather than the exception in the ocean. So all of the things that animals have to do on land, animals in the ocean have to do. They have to be able to find food, they have to be able to find mates, and they have to be able to defend themselves against predators. Well, bioluminescence plays key roles in all of those things. So they can use the luminescence to attract food to them, and they do it in a bunch of really interesting ways. or they can use it to be able to see their food. So a lot of them have built-in flashlights under their eyes that they can see with. So it gets used for finding food, for finding and attracting mates, and then it gets used a lot for defense. And they'll release particles or just luminescent slime into the face of a predator. There's some that use it as a way to communicate the fact that they taste bad, I'm poisonous, don't touch me or you'll be sorry. Some that use it in something that's called a bioluminescent burglar alarm. And these are some of the most spectacular displays, because if you're caught in the clutches of a predator, your only hope for escape may be to attract something bigger that will attack your attacker.
I absolutely love this video, and I love Edie Witter. She's such an energetic scientist and so excited about what she does for a living. And there are multiple TED Talks of her. I think there's 2 of them that might be in your resource sheet talking about bioluminescence. But this video is about 4 minutes long, and there are a few questions about this video that students can answer on their worksheets, numbers 15 and 16, noting the colors of light created by deep sea organisms, the purposes of bioluminescence, and other observations that they might have from the video. And then the lesson continues on to offer a couple of different options for reading exercises on the right-hand side of that page. There's a link to the bioluminescence fact sheet and to a Smithsonian article that is specific to the colors of bioluminescence, and a number of additional guiding questions to help students build more ideas. And the goal of all of this here is for students to understand that there are a variety of behaviors and reasons for bioluminescence, and to come to the conclusion that blue really is the primary color used for bioluminescence. And given that blue is the most abundant wavelength in the deep ocean, the organisms have evolved to create blue light that can attract attention. And then at the end of page 9, there are a number of options for you to dig a bit deeper if you so choose. But the full point of this activity is for students to build their understanding that the ways color and light work in the ocean help us understand why deep sea organisms are particular colors and why so many of them use blue bioluminescence. And lastly, at the top of page 10, we get into the evaluate section. And here you can have the students draw a model of what they learned about the phenomena and have them include an animal of their choosing at the surface and at depth. And the diagrams should include as many of the introduced terms as possible, and also what color the organism is and what at the surface and what color it is at the depth that they placed it. You also have a list of a number of different extensions to explore bioluminescence, including the activity that you'll be looking at in your follow-up, an adaptation for deep sea survival, which explores why so many deep sea organisms glow in the dark. And finally, I just wanted to note for you that at the bottom of this entire activity, on the last page, there are hot links to all of the links on each page throughout the entire lesson. So a quick, easy reference for all the things that you might need. So I suggest that you bring this activity and your questions to your follow-up, and bring your general thoughts as well for lots of great discussion with your colleagues. And if by chance, between now and your follow-up, and I know that's a pretty short time, if by chance this activity fits into your instruction in that time, we'd love to hear how it worked for you, and we'd love to see some images of your student models. And even if you do this a little later in the year, if you send us your student models, we'd absolutely love to see them, and we can incorporate them into future professional development. So with that, I hope you enjoyed the activities, and I'm going to turn it over to Liz to talk with you about resources.
Thanks, Susan. I'm really excited to share with everyone all of the online resources that are available to cover this topic. I absolutely love bioluminescence, and I hope you guys are geeking out tonight as much as I am with all of the great information we've heard so far from both Renee and Susan. What I'm going to do is start with the resource for educators. This is the document that Alexandra shared in the email earlier this week. As you'll see, there are a ton of links here that are available to you, and these were just resources that we've pulled and used over and over again that are a great way to bring bioluminescence into your classroom. There's a few I want to highlight here tonight, just because Susan and Alex have mentioned them a couple times. And that includes the activity, which Susan just presented. That's actually the first link that is here. And then the fact sheets and exploration notes. And these are all brand new resources that were just developed, honestly, within the past month. So they are hot off the press. And like Susan said, we're really eager to get some feedback from all of you on how you use those in your classroom. Another one of my favorites that's on this website is the interactive from Dive Discover. This is a WHOI online interactive, part of their series. It's just a really fun, they've got a couple different modules here that relate to bioluminescence and some of the topics we talked about tonight or that were covered in the Deep Sea Dialogues video that you watched prior to tonight's event. These are great interactives because your students can actually click through at their own pace and figure things out on their own. Again, some of those TED Talks that Susan mentioned are also linked here, as well as some image galleries and videos to really show off some of the really cool adaptations that Renee talked about tonight. Since a few of you asked in the chat, I also wanted to point out Renee does have a website, and maybe I can get some help showing that link or URL across the bottom of the screen so you guys can see it a little bit bigger. But that is lampichthyes.com. And her website, if you enter, is also where a lot of you asked to see publications that relate to bioluminescence. So there's several here, as well as some of her outreach and the art that she was mentioning as well. Now, at the bottom of your resource sheet, there were 4 websites that I kind of want to take you on a tour of. And so I'm starting down here, and I'm going to start with the Noaa Office of Ocean Exploration. And our website has tons of resources available for teachers, but they can be a little hard to find. And so I really want to navigate you guys through the site so that you can use them in your classroom with your students. And so we're going to start on the Education tab at the top menu and head to the theme page. And so here we have several themes. And as Susan mentioned, you can use the ocean to cover really any science topic in your classroom. And so we decided to bin these instead of by biology or chemistry. These are themes that kind of bridge multiple science subjects. As you'll see, bioluminescence has its own tab. And within there, we've got background information. And this is where you can find fact sheets, essays, which come from our expeditions, exploration notes as well, and other stories from the field that you can share with your students. All of our lessons are linked here. I will say the newest lesson that Susan presented tonight isn't quite up yet on this page, but you can follow the direct link that was shared with you on that resource page. They'll be up soon. Again, some multimedia that you can check out. So these are images and videos that come from our office and our expeditions throughout the years. And if you're really interested to check out some of the earlier expeditions that our office has led exploring bioluminescence and other examples of light in the deep sea, some great resources down here in the expeditions tab for that. And this is Dr. Edie Witter, whose voice you heard on some of the videos. She's one of our career profiles also featured on the website. So another resource for your students. And the next website that's listed on your resource sheet is the Nautilus Live website. And so this is from Ocean Exploration Trust. They also have a number of resources available for bioluminescence. Again, if you head to their education tab, and then here they have theirs organized a little bit different. So you've got to actually head to specifically their education resources, although I encourage you to check out some of their other links as well. And once you're on this page, you can browse by theme, and they've linked theirs by more of your STEAM categories plus career resources, types of lesson, but they also have an advanced search filter. And so to find bioluminescence, I just happen to know it's an activity or mini lesson, so I'll take you there. This is also linked directly to your resource sheet, but they do have an activity called the Chemistry of Bioluminescence. So again, another awesome classroom resource. They also have some blogs and some videos that are really interesting, and the best way to find those is to just search bioluminescence on their site. And you can see some of their top blogs, and these are from their latest expeditions. And this video here is fantastic. So really cool awesome one to share with your student of some of the shape-shifting abilities of a bioluminescent creature, as well as some team member profiles. And so these are some of the explorers that have been aboard expeditions where bioluminescence and light in the deep sea were covered. Next up on the list is the Schmidt Ocean Institute website. Again, they have some awesome resources. I would say their specialty is definitely videos and imagery. And so to find their bioluminescence content, again, the easiest way is to just search it. And you'll get a list of all of their latest content. And so again, they've got some explorer profiles, some log posts, which are really neat because you can actually see these are stories that were written and drafted during the actual expeditions. So you get some of that firsthand perspective of what it's like to study bioluminescence at sea. And they've got some cool resources too that go over both the artist at sea connection and some of the technology that is used at sea to study bioluminescence. And because I know all of this can be really overwhelming, the last website I kind of want to end on tonight is a brand new website that just launched on World Ocean Day this past summer. And so that was just June 8th, so it hasn't been around that long. This website was developed in collaboration with the National Marine Sanctuary Foundation. And it's a collaborative ocean exploration education resource hub. And so it features educational materials from Noaa Ocean Exploration, Nautilus Live, and Schmidt Ocean Institute. So all of the 3 websites we just toured all housed in one place. So rather than combing through all 3 sites, you can just head to deepoceaneducation.org and you can find those resources from all 3 located right here. When you land on the site, we really wanted to make it as easy as possible to find what you're looking for. So start off with an advanced search feature. We've also got featured content, which gets updated very frequently. And you can see we've got different topics covered with those resources and quite a diverse set of resources. So there's some career profiles, activities, image galleries. Basically, the newest content that is coming out of these offices is going to be featured here. Also on the homepage, each of these organizations has a research vessel that is dedicated to ocean exploration. And so you can see the We're Live symbol here. This is a really special time because all 3 are actually at sea presently. And during the daytime hours, at least, all 3 live stream the ROV dives. So really cool thing to bring into your classroom and connect. And even if it doesn't fit into your current curriculum, honestly, I love to just have the dives in the background while I'm doing work. It's really cool to kind of hear the excitement from the explorers as they're finding things live. Some other key things on this website, as I mentioned, it's got resources from all 3 organizations, and we've got them organized by 12 key themes again, as well as easily searchable down below. If you're really hunting for something specific to support your classroom and your student learning, as soon as you filter for student activities, you get some advanced search filters that include grade level, next generation science standard. We decided to focus on the DCIs, and you can also filter by discipline. And so these are some of the more traditional science disciplines by subject area. Once you find a resource, you'll see a couple options here. So you can read more and actually head to learn more about that resource. Here's that chemistry bioluminescence that I showed earlier. And once you head to that page, you've got all of the actual activity components available for download. A lot of these are in an editable format so that you can adjust them for your students as needed. But my favorite feature of this site, you notice the Add to My Collection button. If you click that, and you can see I'm already logged in. So I've got my demo account open. But if I wanted to add this to my bioluminescence folder, all I would do is log in. And if you're new to the site, it's going to ask you to create an account that is a free resource for you. And a collection is just like a folder. So everything that you see on the site can be saved. You can build as many folders or collections as you'd like. And even within the folders, you can add some headings and organize content there. And if that's not enough, you can also share everything that you find on the site with a colleague, and all you need is their email address. So really great resource that we hope you use. Again, brand new, and we'd love to hear what you think about it as well. Some extras on the site that would be really helpful for our audience tonight. We've got the events and opportunities. And so this is the place where we advertise things like the professional development you're participating in tonight, as well as live interactions. We've got one coming up with our office later this week. And this one's really cool because it's actually with the White House Office of Science and Technology and the Smithsonian National Museum of Natural History. So please check that out, as well as some programs for all of you to participate in below. And these programs are both for teachers and for students. And last but not least are the vessels page on this site. As I mentioned, it has the ship trackers here. So it has that We're Live function. And if you click that, it's going to go straight to the live feed. But also what's really cool about it is you can see just where in the world all 3 ships are exploring. And these are live ship trackers from all of the 3 current expeditions. So Nautilus is out in Hawaii. Schmidt is off the coast of California. And our office is exploring off the Southeast US. And say that all of these actually said we're in port. And so it's not a great time. It doesn't happen to be a live feed. If you scroll down to the bottom of this page, you can actually see the calendar and you can look for a time where you could actually find the live stream, because all 3 of our offices, for the most part, if we're at sea, we are live streaming ROV dives. So again, great way to bring the ocean into your classroom. All right, and with that, I can stop sharing my screen. And that's bringing us to the conclusion of the event this evening. Just a reminder that this is just the first live event. So later some of you as soon as a week from now and some a month from now, but there is a follow-up event, and this takes place with one of our alliance partners. So I'm going to bring those back up on the screen. So dates and times for those alliance partner follow-ups are as followed. So the Albuquerque Biopark, their follow-up will be November 16th at 4 p.m. Mountain Time. The Dauphin Island Sea Lab will be December 7th at 5 p.m. Central, and I'll see you guys there. The Great Lakes Aquarium will be November 12th at 5:30 Central, and Loveland Living Planet will be December 2nd at 3 p.m. Mountain. So make sure you attend that session as well. You have to attend both in order to get your stipend, but also we will be sharing additional resources at those follow-ups, including a second activity for you to bring into your classroom, all about the adaptations, including the ones that Renee featured tonight. We look forward to offering more of these events in the future. In the spring, we are looking to host professional development opportunities on deep sea corals. So stay tuned. That last webpage that I showed you, keep following along with the events and opportunities. We'll be posting all of those there. But before we sign off for tonight, I really want to give a special thank you to our guest, Renee. And if she doesn't mind, I'd love to bring her back because I've got 2 questions I'd love to ask before we sign off for the evening.
Yeah, absolutely.
So one of the questions that came in the chat while I was talking was, what is the coolest thing that you have seen in all of your studies and exploration?
It's really hard to pass up talking about going on a deep sea trawling expedition. And we were off the coast of California, really similar to where I think it was Schmidt is right now. And honestly, when you pull up a trawl that's been in the deep sea for like hours, and again, this is your boat has to be going slow, and your winch has to be going slow because there's a ton of water pressure behind that net. Just actually seeing organisms that are bioluminescing just like in front of your eyes is, to say the least, one of the most amazing things that I've ever experienced, including, like they were saying, jellies and lanternfishes. Like, it's hard to see during the day, but when the trawls would come up at night, especially, you would actually see these flashes of light. And so that expedition has been a highlight of my career so far. And I really do hope that I get to go on more as I finish my PhD and then move into a position somewhere.
That's really special. And I'm glad that you brought up the point that those trawls are coming up at night, because I don't think a lot of people realize that when you're at sea, every hour is precious. And so you have work going around the clock.
We would work 12-hour shifts. And honestly, like, even if you weren't working your shift, you still would be up and ready for the next trawl, because I think over a 4-day period, we had 25 trawls come up. And so you wanted to be there, right? Every new one that you pulled up could have something new and different. And so you were just awake whether or not it was 2 a.m., 5 a.m., or 8 p.m. You were there.
I love that. And your enthusiasm is perfect for this next question and our final send-off for the evening, which is, what does the future of ocean exploration look like to you?
So I think that, at least in particular to the research that I'm doing, my view of ocean exploration and the way that I would like to see it go is to continue to create better visuals and better cameras and better light systems and better ROV systems for researchers like me trying to study organisms that are living in the deep sea, to be better able to look at the behaviors that are happening down there. We do get these trawls and we're able to pull them up, but the deep sea is a highly pressurized system, and a lot of the specimens that live down there have not evolved in a world where they can get tossed around a lot, either like nearshore coral reefs where you've got different currents and you've got tides. Like, the fish that live here haven't had to bump into anything in their entire life. And so they're very delicate, and bringing them up damages a lot of them. And so being able to witness these behaviors down in the deep sea, being able to see them bioluminesce, even though we have the knowledge and we have seen some of these things, getting that camera down there and getting all of that on film is still something that we as researchers in the scientific community are continuing to develop. And so I think, and personally, that is and will be an amazing aspect to see and shift and grow throughout my career.
That's a really interesting point. We've talked a lot about the science of bioluminescence tonight, but another great way for these young students to get interested in this field is to go through the engineering side and technology.
Yeah. Mm-hmm.
So really great point. And again, thank you for joining us tonight. We're really lucky to have you. For those of you, if we did not get to your question tonight, please feel free to email us. On the bottom of the activity that Susan shared tonight, there is an email to our Noaa Ocean Exploration Education email. And if it's a really, really interesting question that we can't answer, we'll be sure to reach out to our experts like Renee and hopefully get you an answer before your follow-up.
Thank you again for having me. I had a great time.
Awesome. And before we completely wrap up tonight, again, I just really want to thank our Inner Space Center and Foundation partners, as well as the Ocean Exploration Cooperative Institute and Ocean Exploration staff behind the scenes. Without any of them, these events would not be possible. And we look forward and hope to see you guys in future events. Again, check back for spring 2022 dates.